they give us that AD is 50, AC is 36, segment BD is 27, and we're trying to find this distance right here, okay? So looking at this, if I have this is 50 and this is 27, then I know from A to B that that has to be 23, right? So I know that this distance here is 23. Now I know the total distance from A to C is 36, and if this is 23, then this is just going to be 36 minus 23. And so BC has to be 13 units long. Okay, we're trying to find the distance between 2 points on a coordinate plane. So we're going to use the distance formula. So as a refresher, the distance formula is just the square root of the difference of the x values plus the difference of the y values. So if you remember, this is really just the Pythagorean theorem, because this would give you one leg of the triangle, this would give you the other leg of the triangle, and that equals the hypotenuse squared. But if you take the square root of both sides, you get this. So, so now that we have this, we can go ahead and plug in the points. So for me, when I look at this, I'm trying to find how far apart the x's are. So I'm going from positive 12 to negative 15, and that's going to be 27 units apart. All right, now you can certainly plug that in, but I'm just going to write 27 squared versus writing negative 15 minus 12 or 12 minus a negative 15. All right, plus negative 9 and 17, that's going to be 8 units apart. Okay, so then if I plug this in, 27 squared plus 8 squared, square root of that is not a pretty number, so let's go ahead and get the exact value. 27 squared plus 8 squared is the square root of 793, and that's approximately 28.16. All right. M's the midpoint of CD, and they give us the midpoint, and then we have the coordinate for C, and we're trying to figure out what point D is, okay? So let's go ahead and refresh for midpoint. So the midpoint between 2 points is the average of the x values and then the average of the y values. Now again, to kind of remember this, right, the distance, we're getting one number, and that's how far apart they are. When it wants a midpoint, it's specifically looking for a point, okay? So here's the thing. If the midpoint is negative 1, negative 1, negative 1, comma 1, okay, then what's happening is if the coordinates of point C are 1, 3, then that's going to equal 1 plus x over 2, comma, and then negative 3 plus y over 2. So that means that these two have to equal each other, right? The x values have to equal each other, and the y values have to equal each other, okay? So this takes a lot of algebra, and most of you guys are not really wanting to do that. So the other thing you can do is draw a graph. So we have, okay, so it's going to be over here. So I have 1, negative 3. So this is C. Now the midpoint is negative 1, 1. Now that's important because if this is the midpoint and this is C, then D has to be somewhere up here, okay? Now, if this is a segment, then the slope is going to remain the same. So this means I go left 2, and then up 1, 2, 3, 4. So left 2, so I'm subtracting 2 from x, and I'm adding 4 to the y value. Okay, and then if that's the case, we want to do that again. So if my midpoint is negative 1, then for point D, I'm going to go left another 2, so negative 1 minus another 2 is negative 3, and then just like I went from negative 3 to 1, I added 4, I need to add another 4, so that's going to be a 5. So that is the easiest way. But if you're unsure of how to do this graphically, algebraically, again, you can set this up. So then we would have negative 1 equals to 1 plus x over 2. I multiply both sides by 2. Negative 2 equals 1 plus x. Subtract 1 from both sides, so x is negative 3, just like we found. And then we can do negative 3 plus y over 2 equals 1. So multiply both sides by 2 again. Negative 3 plus y equals 2. And then I add 3 to both sides, and sure enough, y equals 5. So 2 ways to do the same problem. Okay. For number 4 on here, we want to find the perimeter of the isosceles trapezoid. Okay. If it's an isosceles trapezoid, that's great, because that means these two lengths are going to be the same. So what's going to have to happen here is I'm going to need to use the distance formula at least 3 times, because I need to use it to find the distance for BC. I need to use it to find the distance for AD, and then I need to use it to find AB, which is equal to CD. Okay, so let's go ahead and find BC first. Let's go ahead and label these points. We have 3, 1. Over here we have negative 3, 3. A is negative 5, 2. And D is 4, negative 1. So if I'm finding BC, that's going to be the square root of the distance between the x's. Negative 3 to 3 are 6 units. The distance between the y's from 3 to 1 is only 2 units. So 6 squared plus 2 squared is going to be root 40. And then for AD, the x's to go from negative 5 to negative 4, that's 9 units apart. And for the y values, 2 to negative 1 are 3 units apart. So 81 plus, did I do that right? 81 plus 9 is going to be root 90. And then let's go ahead and use CD. So that's going to be, the x's from 3 to 4 are 1 unit apart. And then to go from 1 to negative 1, that's 2 units apart. So 1 plus 4 is root 5. So the perimeter is going to be the sum of all 4 segments. So I have to add all 4. So that's going to be root 40 plus root 90 plus 2 root 5. Okay? So let's go ahead and simplify. Root 40 is 4 times 10. So that's going to be 2 root 10. 90 is what? 3 times 30. Can I pull anything out of 30? 3 root 30. I think that's it. Plus 2 root 5. So this is actually as much as you can simplify it using an exact value. Okay? And again, the reason why this is 2 root 5 is because this side is root 5 and this side is root 5. So we have twice as much. All right, and then the last one, the distance between the points is given, and we want to figure out what A is. So there, again, we're using D equals a square root, the difference between the x's squared plus the difference between the y's squared. Okay. So let's go ahead and let this be x and y, and this is going to be x1, y1, and this is my distance d. All right, so if that's the case, I get root 13 equals the square root of 1 minus negative 1 squared plus a minus negative 4 quantity squared, and we need to solve, so I'm going to square both sides, and then I'm also going to simplify inside. So this becomes 13 equals, well, this is 1 plus 1, so that becomes 2 squared, and that is 4. And then this becomes a plus 4 quantity squared. Now notice I didn't simplify this yet because this is a binomial, so you need to remember that a plus 4 quantity squared is really a plus 4 times a plus 4. So that's going to end up being a squared plus a times 4 is 4a, 4 times a is 4a, so plus 8a plus 16. Okay, so this becomes 4 plus a squared plus 8a plus 16. Now notice I have a quadratic. If you have a quadratic, you need to set it equal to 0. So I'm going to subtract 13 from both sides, and here I have 20. So I end up with a squared plus 8a, and then 20 minus 13 is 7. So this becomes a, what two numbers multiply to 7? Add to 8, that's a plus 7, and that is a plus 1. So therefore, a could be two different numbers in order to get the distance to be root 13. The two numbers are going to be -7 by the zero product property and -1.